Hey guys, my name's Andrew Dahlen. I'm here at Northland Community and Technical College, and I'm here to talk to you guys about a few tips related to working with the large shafts in the VEX Robotics platform. The new motors that we have, the V5 motors, are physically larger, they offer more torque, and they will accept this large 1/4 inch shaft, and in fact they have so much torque they're able to twist the smaller 1/8 inch shaft, and it can be a problem. So now I think teams are going to start working more with the 1/4 inch shaft. So I'm going to show you a couple of tips that I've learned along the way. These large shaft collars take up about 1/2 inch of material, and in an application like this where maybe you don't want to have that large shaft collar sticking out, take a look at what we've done here. If we drill and tap the end of the large shaft, we can eliminate the need for those large, bulky collars. So instead of having a large, bulky collar on the top side, if we drill a hole and then thread that hole with a product called a tap, we can just screw a screw into the end of it with a washer, and that keeps the entire thing captive. Here's another application where that's been used on the end of this shaft. So we drilled and tapped the end of the shaft, and instead of having a 1/2 inch collar stick out of here, and when you're trying to save room on your 18 inch by 18 inch robot, a 1/2 inch can make a big difference. So this is pretty much keeping that shaft in place with nothing more than a screw at the end of it. So we put together a little kit to help out in getting that shaft drilled and tapped on the end. So we're going to take a shaft that we'd like to have drilled and tapped on the end, and in this kit we have a fixture block. That fixture block will clamp onto the end of the shaft, a couple of thumb screws, and then it's got the correct size through hole for the drill and tap. So in order to form threads, if you've never done this before, you use a drill that's a little bit smaller, and this thing that's called a tap. This is an 832 tap, and the process is we'll drill through this, and then we'll use the tap to form the threads in the end of the shaft. So first things first, you're going to need safety glasses to make this happen. What we'll do is to clamp up the shaft in the vise with this drill fixture installed on it. Get our drill bit chucked up. You'll want to use a high speed on that drill bit, and it's nice to use a little bit of cutting fluid or some sort of lubricant for the drilling and cutting. This is going to line up the drill bit concentric with the end of the shaft, and we just go ahead and drill that down to a depth of about maybe 3/4 of an inch. Now we're taking our time and letting the drill do the work. We don't want to be pushing down too hard, or we run the risk of snapping the drill bit. The other thing we'll do on occasion is to lift the drill bit up to clear some of the chips out of the hole. There we go. The end of the shaft has now been drilled, and we can loosen up the thumb screws, remove the fixture, and there we've got this shaft with a hole drilled in the end of it. Now, in order to form the threads for the screw to go into, we're going to need a tap. This is an 832 tap, and this is a tap handle. Clamp the tap up in there, apply some more of that cutting material, the tap ease cutting lubricant, and now we're going to tap the end of this shaft. You'll want to try to get the tap to line up as straight as you can with the shaft, and we just slowly go in. If you feel any resistance, you'll want to back off, or about every couple of turns it's nice just to back the tap up, and that's going to clear any chips and prevent the tap from breaking, and that is a risk. Your tap could very well break inside of that shaft, especially if you try to put any force on it this direction. you'll want to make sure that you're pretty much just applying a twisting force and not loading it in any other way. And if you do encounter resistance, we just back off. And once you get to the end of the hole, you'll feel the tap get kind of solid and you can't go any further. So we're backing this all the way up, and we should have formed the threads in the end of the shaft. All right, clean off any of the lubricant that's left behind there. And at that point, we should be able to just screw one of our 832 screws right into the end of that shaft. And I've got a washer on it in this case too. And that is going to be all it takes to hold that shaft in place. And it takes up way less room than using one of these very large collars. Very big difference here. And again, when you're trying to save all you can in the real estate of the robot, this is important. So this is way smaller than the clamping collars that VEX sells with it. One other tip is when you have to drill holes for the large shaft to go through the metal parts, the metal structure parts, I recommend using a step drill. So we're going to clamp this up in the vise, and this is a step drill. They can be picked up at most any hardware store. The advantage of this compared to a regular drill bit is that it doesn't grip as much. So we can simply chuck that up in the drill bit, and it self-centers on the hole as you drill. Now you'll want to be cautious so you don't over drill the hole, but that's perfect. It's able to clean it up, drill those holes nicely, and you're able to get the shaft through. Now this creates a little bit of a burr on this back side, but if we clean that up by running it across the back side, we can remove that excess burr and we get a very clean hole that's the right size for the shaft to go through. So those are a couple tips and tricks related to working with the VEX Robotics large shaft, drilling and tapping the end of the hole. I hope you guys enjoy this, and good luck.